Hello, and thank you for joining us for this session on the power of TrueSight Imaging, where images have never looked better. I'm Paul Thompson with Waygate and the Visual Business, and I'm the Global Manager for Training and Technical Support. Joining me this evening are Tom Britton. Tom is our Global Aerospace Senior Sales Manager, and also joined by Tom Britton. Tom is also a Senior Product Manager and is responsible for the Mentor Visual IQ product line, which is that instrument that's on your screen. So there's a few housekeeping items that I want to cover first. At the bottom of your screen are multiple application engagement tools that you can click on, and they'll pop up or go down. And all of the engagement tools, you can grab the bottom right corner, and they're resizable. You can click on the top and move them around. So get your desktop set up the way you want it to look. Some of the materials I'm going to present tonight are via slides, and some of the materials I'm going to be showing you will be from a live presentation on the Mentor Visual IQ. So as such, I'm not going to spend a lot of time reading these slides to you. You'll be able to download that material and read it later, but I will cover the essence of them so that we have enough time to both answer questions from you, but also show you some of the new technology that's going to be released in this Mentor Visual IQ in a new software release in the next week or so. If you have any questions during the webcast, you can submit them through the Q&A engagement tool that's down on the bottom of your panel. You can pop it up. We'll try to answer every one of your questions during the webcast, but if a fuller answer is needed or we run out of time, we'll definitely answer it via email, or if you would like us to call you in your question chat, please post a phone number or an email. We can get back in touch with you. So also a copy of the presentation, like I said, from today is going to be available. There are links and other resources that are there, and we encourage you to download them and use them to your best advantage. So with that, I'm going to start talking about TrueSight Imaging, and you may wonder why we call it TrueSight. A lot of video borescopes out there, and they have lighting, they have cameras, some of them articulate, and not all of them pull that together. It's a combination of technology that we've created and bundled into this TrueSight Imaging package, where it's not only a super high resolution camera and not only precision made optics that we manufacture ourselves, but it's also a powerful suite of proprietary image transformations. And that may be a new term for some of you. These image transforms, we're going to get in quite a bit deeper in this conversation. And the whole idea is to be able to take a function or a feature or a visual presentation on an image and manipulate it so that you have a better chance for probability of detection. And we have three flavors of these Mentor Visual IQs or Visual IQs, and the one that has the most capability, it's like the rocket ship of the fleet. It has any of the capabilities that we're going to be talking about, and then two of the other space shuttle or lower level system type of Mentor Visual systems. They can be added a la carte so that you don't get any more than you need, but they're all available to you through a la carte or through the Mentor Visual with everything in it. I'm going to spend some time talking today about these transforms, especially adaptive noise reduction and dark boost and distortion correction. And those are the ones that are available, like I said, as apps. But I want to show you how to use them to get the most out of this instrument. So this is a list of all of the things that are a part of TrueSight Imaging. First of all, we have a 1.2 megapixel camera in there, and tying that together with image settings of brightness and dark boost and inverse plus and adaptive noise reduction. These are all tools that are available to you, and we've added in this next release of software coming out in a week or so, the ability to rotate an image and some other really interesting features we'll talk about. I'm going to focus a lot on dark boost and image brightness and inverse plus, because if you're one of those people that are going to be measuring, I'm going to want to make sure you know how to use those pieces of technology to get the very best out of your instrument when you're measuring. Let's talk about this sensor first. That's the camera imager that's out on the end of an object, And, the thing about resolution, it's a measurement of what the imaging system's ability is to reproduce object details, and it can be influenced by factors such as the type of lighting that's on the scene, what the pixel size are on the imager, or what the capability of the optics are. And Edmunds Optics defines that as the smaller the object detail, the higher the required resolution. So that's what I'm talking about when we went to the highest resolution video borescope camera available today in a 6.1 millimeter package. It's capable of not only measuring up close, but it's also able to measure from far distances now with a far focusing real 3D scanning lens that allows you to measure from 3 times further and over a greater volumetric area of, say, 100 millimeters or 4 inches in size volumetrically across that area. And so the idea is, if you're looking at this picture on the right, this camera was almost 2.7 inches away. It was looking at this U.S. Air Force 1951 target at the element group 0, G0, that's the group 0, element 1, that's the E1. If you look in the table for that standard, that grouping is 0.0394. And so from almost 3 inches away, I was able to make that measurement within plus or minus about 2%. Part of that's because of far focusing optics. Part of that's because of this high resolution imager. I hope you'll join me on another session later where I will be talking about real 3D in a lot of detail. So when you're looking at this Visual IQ's resolution and that 1.2 megapixel imager, it's simply rendering a larger image that you're going to be able to save and work with post-inspection. It's going to render a high-resolution image for video. And if you look on the right side, this is the back of a U.S. $1 bill, and you can see the detail difference when you're zooming in on a standard definition, which is still available. It's still a really good camera, but when you need detail, this 1.2 megapixel is beyond anything we've ever had in 440,000 pixels or what competitively is available out there in, say, 800 megapixel kinds of solutions. Just to show you a little bit closer picture of what that HD resolution with a close focusing optic is able to do. This again is that U.S. Air Force 1951 target that was NIST, National Institute of Standard and Technology, certified, and that Group 5, Element 3, has line pairs, a black line and a white line, that are 0010, so 1,007 inch. And so I was able to make that measurement by using high dynamic ranging, by changing the image brightness, by using some zoom windows so that I could precisely place those cursors on the location and measure that exactly with what it was being presented as. Just a picture of the long range that I talked about earlier. You know, our traditional lenses are showing a much smaller volumetric area, say 34 millimeters by 50 millimeters. Well, this far focusing lens is able to get out to, say, some 110 millimeters to 167 millimeters to let you measure at a larger distance, okay? When you get ready to measure, or even if you're not measuring, you're simply analyzing a scene, this is when you want to be able to use these image transformations to your advantage. You can see that there are a dozen of these available to you. You know, if you're transforming the image brightness from bright to dark, gamma adjustment across the scene, or lighting across the scene, that's what we call the dark boost. But there's 12 different transforms that are available, so you can make the image that you're looking at appear as realistic and give you as much detail as possible. And we'll talk about that. First, let's look at high dynamic ranging. We recently released a high dynamic ranging that has a variable adjustment. So if you have a smartphone and you have HDR on it, you know that when you take a picture with HDR, the darker areas are brought to brighter and the brighter areas are taken down to a level so that you have a evenly lit image across the scene. So that's what HDR is. And variable HDR allows you to set the brightness set point across that so that when it's looking at a bright image, a dark image, and a normal image, you can set the set point for that to function. So this would be an example of looking at an image without HDR, and then if you turn high dynamic range on, it's capturing a series of bright and dark images. So would you want to know something about this weld on the left, the solder joint, or would you be able to more accurately be able to tell something about this weld joint on the right? And if you don't have high dynamic ranging, you can also play with the lighting. You can turn the brightness up or down. You can turn dark boost up and down. You can play with the lighting, brightness, dark boost, and you can change those to ultimately get a decent image. Here's an example of what that HDR image would look like. This is a JT8 burner can. The fuel nozzle's down at the far side. This object was stuck into the path just so you know that sometimes images close to the camera are going to be brighter, and the camera adjusts for that, and so you can't see past it. Well, with high dynamic ranging variable, you can adjust the HDR so that I can now see the fuel nozzle that you can tell is back there on the image on the left. But in the image on the right, you're able to see the blade that's inserted in the image right in front of you, but you're also able to see at a further distance. When you have the variable portion, like I said, this is just simply letting you put sliders on the screen by going to variable HDR and adjusting it across a wider range to get better images. So some key takeaways here is that HDR is available on a freeze frame image. So if you freeze the image, you'll see views on the bottom of the screen. And if you have HDR capability, you'll be able to see it on the screen, and you can select bright, dark, variable, and adjust it. And it's really handy when you have reflective surfaces and when you're looking at areas that you want to measure, especially with stereo measurement, you can adjust the high dynamic ranging to get better pixel pattern differentiation, which is critically important with stereo and 3D stereo. So it's that tool that's allowing you to change the brightness and darkness on the scene to get better imaging and also allow you to have better and more precise measurements. Now, having talked about all that, one of the things I'm interested in is when you're teaching a new borescope inspector, how to do borescope inspections, what tasks do you place the greatest emphasis on? Is it something to do with adjusting the camera to set it up or getting the camera to the work site? I have some poll questions that you should be seeing here, and I'd like to look at that and consider those for my questions and answers on the follow-up. Just give you a couple of minutes and let those come in. Click on the radio button that's most applicable for you. Okay, I'm going to then push those out so that you guys can look at them and see what people are saying. How do you set up this instrument for best results is like the number one thing that you as an instructor or a mentor would want to teach your new inspectors. And all of those transforms that I just mentioned can actually be set up and saved in a preset so that you don't have to go back every time you're looking at a particular asset and adjust them from start. So let's also talk about brightness because, like I said, lighting is not everything. You have a bright screen, a dark screen, and you can change that, but it doesn't just change the brightness. It also changes data that's flowing in from outside world through the camera in through the insertion tube and back to the processing circuit. So you have lensing, you have lighting, you have a camera. You have digital converting circuits and analog to digital conversions. And not only that, these tip optics out on the end are better suited for different kinds of inspections. So if you're working over larger areas and you're wanting to get better results out of, or more noticeable results, all the way from these measuring tips out to far focusing tips is where you're going to really see the difference in high definition. And then there are a number of things going on when you adjust the brightness on your screen. When you go to image brightness and start turning it up or down, it's adjusting the exposure, meaning the electronic shutter speed. It's changing the gain, meaning it's giving more or less gain to the camera. It's also adjusting the brightness of the screen. And then at the end of the range, when you start bringing brightness down even more, you'll get to a point where it will start attenuating the light output from the camera. This is just an example of what happens with gain. If you look at the picture on the bottom, there's a very high gain image with no reduction in that gain. It's so grainy that it's not that clear. And while it seems a little soft focus on the top, you can certainly still make out details where that noise is not overriding it. So gain is a big issue to work with. That's why we'll talk about adaptive noise reduction in a moment. So some key takeaways here. People were putting a camera in place. They were rotating these turbine blades up on the top right. When the blade got close to the camera, the brightness was automatically attenuating or going up or down, and it was causing blooming or darkness on the scene. And you can actually lock the brightness to a given setting now. That's something that was added in a recent software update. So just keep in mind, like I said, light output is not everything. We have some head guards and ultra bright tips and gray lenses, various lenses that really tend to work well for giving you a brighter image, especially some of them at longer distances. Then let's talk about dark boost. Dark boost is that instrument that will allow you to balance the lighting across the scene. What does that mean? If something up close to the camera is blooming and you can't see beyond it, it's one of those tools that you can adjust and have a bright, well-lit image, even in the background where you couldn't see it before. Very similar to what I showed you earlier with brightness or with adaptive noise reduction, but a little bit different in that it is working with the gamma. Gamma is nothing more than lighting across a scene to try to keep it balanced. And it really worked quite well when you're working on lower signal levels, and when you start getting up to further distances, you may or may not see that kind of relief because the two, brightness and normal dark boost, start trailing in and working together. It's a lot of words to say, okay, what does that really mean when I'm looking at an image? You look at the left-hand side, and you can see that it looks a lot like changing the brightness. I have another picture I'm going to show you earlier, but brightness on the lower left image would cause that weld to glare out. On the right-hand side, you see the weld is somewhat a little more glare, but you see the weld back in behind it down at about 5 o'clock on the image. So data that's back in dark areas becomes much easier to see. So then with dark boost, here's an example that really exacerbates that. No dark boost on the left, dark boost on the right. It's just a way of looking at more data. And here's another one that I was talking about. On the left-hand image, if you look up close on the right-hand side, the right-hand circle in the left image, that is fairly bright, right under the date. It's a fairly bright image, and way off to the left, you can tell there's information back there. You can see structure back there. But until you turn dark boost on, you're not going to be able to see those nozzle guide vanes that are in the right.
Hey, Paul. It's Tom. We've lost your audio. Wondering if you're aware of that, and if you want to give us a sign over the team chat that we're trying to check that, and we'll pause for a second.
So, Tom, let me come off of my earbuds.
Now I'm hearing you again, Paul.
Yeah, it could be the marvels of wonderful internet service, but now I'm on cellular service on my phone. Can you hear me?
Yes, hear you loud and clear, Paul.
All right, Tom, where did you lose me? Can you tell me that?
Yeah, just one slide back.
Okay, in that case, I'm going back just one slide. I was showing this inverse plus slide that says inverse plus reverses an image dark and light area. And folks, I'm not reading these to you just because you can read them when you get them. I want to cover the highlighted nuance of what's going on. And again, what really goes on when we look at an image, like this image on the left, and Tom, just confirm that you're seeing an inverse plus image of the leading edge of a turbine blade, please.
Yep, loud and clear on the audio, and I can see your screen. Yep.
Yeah, so thanks, Tom. When I look at this, I look at that area, okay, I see a little bit of white, but what I really don't see, on the right-hand image, it becomes obvious. When I go to this inverted video feed, you can see this crack on the left-hand arrow pointing at it extends well beyond the leading edge. And certainly when I then go back and look at the white light image, I go, oh, yes, I see that now, but I was missing it. It's just because our eyes are trained to look at an image in a white light world, and when we invert the video feed, things like small cracks, small pits tend to jump out at us and help you with probability of detection. I mentioned adaptive noise reduction a moment ago. When you place the camera in a very large area, and sometimes it doesn't have to be that large, you could just be using a close-up, close-focusing lens, you'll see noise or snow on the screen, and it inhibits the ability to get a really clear picture. What adaptive noise reduction can do is be used in live images, but you have to let the camera sit still so that it can resolve a series of frames and say, okay, I see the image, and it should look like this. So on the left-hand side, you can really tell up on the half disc in the top left of the window, all of the multicolored noise that's in there. And then if you look at ANR, adaptive noise reduction on the right side, that same half moon part of that, it's actually a filter element. And down at the far end of that filter element, I can see it much more clearly because I've turned on ANR. And so, again, adaptive noise reduction works well when the camera can sit still, take a look at the scene and understand what it's looking at, and then adjust for the noise and filter it out. And like I said, it's useful in very large areas. If you don't have ANR on your instrument, meaning you haven't invested in it, maybe you thought you didn't need it, it's still available if you freeze the image. When you freeze frame the image, adaptive noise reduction will be applied to that freeze frame image. And it's in our probability of detection package. If you're wondering how do you put it on your instrument, it's a field upgrade. Again, it's one of those things that are included in Analyze. Distortion correction, we've had that for a while on the flame-colored handsets, and it's really helpful. People that aren't familiar with what it looks like inside of a turbine and a blade comes in view on the right-hand side or the left-hand side, you'll see curvature. They look bent, and distortion correction corrects for that. So, here's an image on the left. So you have, say, a 120-degree field of view tip. The image on the left, you see the right and left edges are curved. Well, they appear curved because of distortion correction that is being applied from the wide-angle lens, where on the right-hand side, when you turn distortion correction on, is going to actually correct for that barrel distortion. You select what tip is on the camera, it knows how much correction to place, and you now have a better picture to work with. Something that we've just recently added, and it's going to be released in software coming to you for the flame-colored handsets, would happen sometime around next week, and you'll be able to rotate an image, meaning if you have a touchscreen, you can put 2 fingers on the image and rotate it. And Tom, I'm just going to take a pause. I just had a network message say that I may have a bad connection. Can you still hear me okay?
Yeah, I can still hear you okay. Your slide's on distortion correction at the moment.
Okay. I'm displaying one that says rotate live images. Is that not showing yet?
Seem to be one behind that.
All right. I'm going to click to the next picture that is showing an actual rotated live image, and you can see that. Just confirm that you can see on the left a blade that's running horizontally across the screen. And on the right-hand side, it's running vertically because it's been rotated 90 degrees. Audio and slides in sync now, Mr. Ward?
Yes, they are.
Okay, thank you. Hey, that's the beauty of doing these things live, and hoping it's coming through to each of you A-OK, and if not, just post a quick message there. So the beautiful thing, helpful thing about rotating an image is different people, especially folks that haven't done a lot of borescoping, they're expecting to see an image in a certain orientation. Maybe they want the blades always to be viewed looking vertically oriented on the screen. Well, you can rotate the image to give you the view that you're expecting. If you're in a pipe and you're seeing water running down the bottom of the pipe, but that water's at the top of the screen, you can now rotate that image 180 degrees. Again, if you don't have a touch screen, there are hard keys that allow you to rotate it. So now you're looking at water running down the bottom of the pipe instead of across the top of the pipe. There's something called overlays. I'm going to show you overlays live here in just a moment, but it gives me the ability to take a picture today and use that picture of a scene today and overlay it to that same scene 6 months from now. I can tell if cracks are longer, or if erosion is worse, or just to have a better way of evaluating the scene. Today it's available in live view. So if you're looking at a live image, you can save that image by double tapping the save key and creating the screenshot, and that really comes in handy also when you're creating those overlays. Okay, so what I'm showing now, Tom, is a slide that says Live TrueSight Applications Image Transformation Reviews.
Yep, we're right there with you.
Okay, so this is where I want to switch over Tom and show some of the TrueSight imaging capability. And maybe if there's like a question that got asked several times about any of that, I would focus on it first. Are there any particular transforms that we have several questions about that I could talk about first with a live demo?
So, no, Paul, there was just one question that had to do with the 1951 target and whether that was a 1951C target. And I'm actually not familiar with that. But the 1951 target is something that we use. It's got a series of lines, and you need to resolve the white area between two dark stripes. And the smaller they are, the higher resolution. And you can get that commercially, and we use it all the time when we talk about what the resolution capability is of our tips. And we'd be happy if you would like to contact us later on to provide some resolution data for a specific application.
Yep. And Tom, I just looked at my slide in a blown up view. It doesn't give any extensions other than USAF 1951 1X. So it didn't have any other alpha designators on that. So, by the way, if you want to know for sure what we were working with, chat us your email. Tom Britton wrote a very detailed paper on the 1951 target, and this is a target that we use in our factory that we had the NIST certification on, and we could certainly share more with you about that. But they are available from a number of sources. Edmund Optics is one of them. The target I showed you was an Edmund Optics target. Okay. All right, so what I would like to do now is get a confirmation from somebody on the call that they are actually seeing an image that has some turbine blades on the left and some other structure on the right. And I'm showing a live screen from my Mentor Visual IQ. So I confirm you're seeing that, please?
Not yet, Paul.
Not yet.
Yes, I'm seeing it, Paul.
Okay. So Tom and Tom, you may not see it on your panel, but if Gina's seeing the same view as our guests on the call, then I'm going to roll. Gina, if that for some reason stops working, if you could just interrupt me and let me know, because what I'm looking at right now, I have my camera inside of a box. If I pull my camera out, you're going to see a number of pieces of structure, and I'm articulating down towards this object that's immediately in front of me, and it's the trailing edge of a turbine blade. If I get right up against that turbine blade and I want to look at the turbine blade very closely at the trailing edge and look at that damage, I'm not seeing the data that's back in the background behind it. So I can touch on the lower left side of the screen. When I say touch, I'm going to be touching icons on the screen. I'm going to touch brightness, and here I can, with my finger, adjust the brightness. Well, okay, that's nice, but now see how bloomed out it is? On the bottom right of my screen is a gray rectangular toggle key. I'm going to tap toggle. You can see my soft keys toggling. And Gina, is that pretty much following one for one?
Yeah, it seems to be.
Okay. If I double tap that, it clears it out. So what I wanted to show you was brightness helped bring the things in the background into view, but the turbine blade in the foreground is absolutely not usable now as far as resolving anything that's going on in that bloomed area and over quite a large area. So I'm going to, in this case, put my brightness back down to a level where that blade looks good. The horizontal turbine blade looks good, but now I want to see in the background. I can touch image. On my image transforms, you see that the gamma symbol of dark boost is on the second top row, and I can now start adjusting my gamma or my dark boost so that it's boosting those dark areas in the background. And if I now say done, you'll notice that my bloom is significantly smaller, and I'm able to see those blades back in the background. So that's the difference there between using image brightness, which is on the top left, or dark boost, which I'll turn it all the way back off, because now I want to show you the difference if I'm using, say, high dynamic ranging. I'm going to touch the screen. You'll notice up on the top left, my screen has gone to FF or freeze frame. On the bottom left button, I'm going to touch views. And you now see I have several selections. There's the normal image that we're looking at right now. It's bordered in orange. And then I have an HDR variable. I'm going to go to that last. Here's my HDR bright. Again, a lot of blooming in the front, but not as bad as it was with brightness. I can go to views and I can look at HDR bright. That's still better than the normal image, right? Just to calibrate, that's what my normal image looks like right there. I can't see the data in the background. But if I go to HDR variable, I can adjust my HDR brightness and get the best image for what I'm trying to see the most of. So now I've got the best of both worlds, brightness. I have high dynamic ranging and the effects of gamma, and I'm not bloomed out on that lower right corner just above that grayed out stereo key. Okay, on the screen lower right, I have a back button. I wanted to show you that. There's a few other pieces of functionality. And Tom, I would just check and see with you guys if there have been any questions come in on anything that people are asking about that I might focus on next.
No, no questions at this point, Paul.
Well, let's spin that up, Tom. Let's rotate. And if I come out of a freeze frame image, I can put two fingers on the screen and rotate. You see I'm rotating the image at the top. If you can see my screen clearly, I've rotated it some 90 degrees, 94, 90. Okay, and you see that it's also bordered on the left. I can two fingers squeeze out to zoom in on that image. And again, why do I want to do that? Maybe I'm used to looking at turbine blades vertically oriented on the screen. Or maybe the engine maintenance manual gives you a picture and says, check the blade this way. I can now rotate my blade to look just like the picture on the manual. So there's some tools that you can use for validating if things look like what the manufacturer says they're supposed to look like. That's one situation. The other situation is, and let me get this erosion. You can see multiple pieces of erosion. And if you're not sure what I'm calling erosion, I'm going to touch the screen. I'm going to touch annotation. I'm going to touch arrow. And I'm going to put my finger on the pointer of the arrow and move it around the screen. I'm going to touch the ball on the arrow. I can spin it to the orientation that I want. And that is what I would call erosion. You say, okay, let's look at it a little closer. Well, a little closer is I'm going to bring your attention to it by changing the color, by changing the size, and saying done. So now I can very clearly send this picture to you, and you know what I'm interested in this picture, but you're still not clear what it is. Let me add some text. Erosion. And I can now move that over by that arrow. I can edit that text with the color. Again, maybe I want it to be orange so it's the same color as the arrow. Maybe I left my glasses at home, or I'm sending it to somebody on the team that is maybe vision challenged a little bit, and I can make the arrow where I want it, or I can touch the text and move it where I want it and say done. So that's something we recently added. So I'm wanting you to know that I have erosion on that image. I can put, if I wanted, multiple arrows because there's actually more erosion. You get the idea here. You know, I can put where there is erosion, multiple arrows, and now when I send this picture to you, what you're going to know for sure is that is erosion, and there's several places that have erosion on it. And let's say I want to use that for my overlay, because today I have erosion. I have just been told by the engineers that I can fly this turbine blade with erosion for 500 more hours. Let me do this. Let me clean up the annotation. I'm going to go in and delete all of these pieces of, you see on the bottom right where it says delete all? I just cleared out everything. I could have cleared them out one at a time, or I could have cleared out multiples. There's something I want you to know about. Maybe you're already aware of it. If I double tap the toggle on the bottom, you see how I cleared out everything except the logo on the bottom left. I was able to do that because when I tap that logo on the bottom left, tap settings, tap image and video, and pull the screen up, I should have touched screen and display, but, I can't remember everything. Where it says screen and display, double tap on toggle hides the UIs. If I choose semi-transparent and tap that toggle key twice or the menu key twice, you see it left some of the data on the screen. Meaning at the top you see the gray status bar, you see the soft keys at the bottom. Double tap the menu key, and it clears some of that out. But if I'm going to save a video with no obstructions, or if I'm going to create an overlay, I'm going to want to touch my Waygate logo on the bottom left, touch Settings, go into Screen and Display, and on the right it says double tap on toggle hide UI. If I go fully transparent and also include the extended UI, you see I have the same screen. Status bar at the top, toggle keys at the bottom, controls for recording, image saving, and back button on the right with the toggle key below it. Double tap the toggle. This is a really clean picture. Now if I double click the save key, watch what happens. Click, click. Screenshot captured to the D drive, screenshot number 7. So I now have that picture saved of this erosion. When I come back to inspect this turbine $500 from now, I'm going to put it into my system and go into image. First, let me go back to a live image. One moment. Just touch the screen and go back to a live image. I can touch image. On the bottom right, you see the eye that is an overlay. And that is not the image I just saved, so I am going to delete that. I'm going to browse, and it was screenshot number 7, so it looks like I'll have to go down to my screenshots. Press enter. Number 7 should be the one I just captured because it said SS07. And you see I've added it. It's my active screenshot, and now I may want to have more or less opacity, so I can make it very prominent or very dimmed or less opaque. And you go, well, how do you know that? Well, watch this. I'll press the back key. I'll rotate my image, and you see the overlay back there? That's in the back. That is 6 months ago. In the front, I'm rotating my live image. And to just show you how opacity plays into that, I'm going to go into image. I'm going to go into overlay. I'm going to toggle the bottom right, go into opacity, and change it to more. Increase that so it looks very similar to my image today, and say done, and then press my back key, and so you see that my overlay looks very much like my current image. And then you can position the camera also, to move your image around and get it to line up with see how the image in the background is moving, and I'll bump it just a little bit and get it to line up. So that's how you can get this system to show you bigger or smaller. If you don't have measuring ability, this is just a really good way to do comparisons of what's going on in that image. To exit out of that, I can go back and reset my transforms, and everything is back to normal. And then you see I still have my overlay. I can go into image, overlay, and hide it. So I'm no longer working with that image and its overlay in the screen. So that was one of the features I wanted to make sure you knew about, because it's fairly easy to use and very informative. The next thing I'm going to move to is in the image, I talked to you about inverse plus. So you see it there on the second row, third key. Before I activate it, we find something else in here that may be remarkable. that we can certainly take a look at differently. So look at this turbine blade. Take a look at everything you notice in there, and now watch what happens when I go to Inverse Plus. And that line on the left, that white line on the left with a black dot at the end of it, those things just jump out. And then if you look to the right where that leading edge impact is, and it has somewhat of a white kind of a hook coming just below it, or a smear, but look at what looks like some kind of indication running from the tip of the blade quite a ways down into the face of that blade. All right, look at that indication and watch what it looks like with Inverse Plus off. Yeah, you can still see it now, but did that jump out in your mind earlier? It's like more of a dark line. A shine has a little bit of reflection in it. So it just helps draw your attention to areas that may not have been as noticeable with Inverse Plus off. Okay? And if you're wondering what I was talking about, I will just freeze the picture. I will go to annotation, put an arrow on the beginning of what I'm calling some type of surface discontinuity, like there, and I'm going to add another arrow, and you see where it's coming in there. Take a look at those, and now look at it with Inverse Plus off. Still there. It wasn't as noticeable to me, and I have seen indications in Inverse Plus that I had completely missed in the white light image before. So use that to your advantage when it applies. And then Tom, any questions that have been posted that you want to share around anything else on TrueSight imaging?
Yeah, we have one, Paul, that I'll try to answer. Claude was asking, I think, is all this software you're showing, is it available on the long steer? And Claude, the answer to that question is, as long as you have our newest model handset, it would be a flame or orange color versus the original gray colored handset that we had. As you look at it from the top view, then you would have all of these features available, assuming you had your software up to date, and in some cases you would purchase that software. Much of the stuff Paul was showing was from the probability of detection software package, which is a feature that we sell for customers to help them identify some of the things that Paul's been sharing. But I'm really happy to also announce that with our new 3.5 software release, it'll be out on November 9th. We're going to provide for anybody that updates their system, again, with the Flame handset, you'll have a 90-day free trial of everything that Paul has been showing today. So you'll get a chance to play with it, make sure you see value in your particular inspection application, and then allow you to make a determination if that's something that you want to have permanently on the system.
No, that's good. So there is a question, Tom, that came in, and it's about measurement, and it's, can we take the dimension of defects and mark it in the image? And so the answer to that is absolutely yes. Again, it follows the line of thinking that Tom Ward was just sharing. If you have one of these instruments, and it could be the gray-colored earlier handsets, or even the earlier XL G3s, or certainly this flame-colored handset, there is a feature called Real 3D. I have a webinar coming up on that next week that we'll get really deep into. And I'm going to just show you one scenario quickly. If I wanted to measure how far that scratch or indication or whatever it is going from the leading edge. First, look on my screen up on the top right, you'll see a circle. That circle allows me to articulate on screen by putting my finger within that square and then locating the image. And you see the little ball moving. Down below that, after I turn that off, I'll get back off up to the top. Down below that, you see a little map that has the ball in the middle. That's telling you where the camera has articulated to. And then just below that, here we are again, Just below that, there is a signal indicator, a signal level indicator. That's a clear sign that this instrument has a 3D phase measuring lens on there. And if I touch 3D PM capture on the bottom right, it's taking a series of a few dozen images, HDR bright, HDR normal, HDR light, but it's doing it with red light. It's throwing a series of shadows out on the target to create what we call a point cloud, where those 1.2 million megapixels, if they're holding data in X, Y, Z. I now have the ability to make several measurement types, and in this scenario, I would typically start with a point to line, where on the left-hand side, I'm looking at the white light image. On the right-hand side, I'm looking at the point cloud image. And when I'm initially placing my cursors, I will go to a full image. And I will put the crosshair on my cursor on what I determine to be the leading edge of this blade. And then I will press the Enter key. I'll place my cursor for the second part of the line measurement out here. And by the way, let me see what's not measurable. All of that red data is not measurable because it didn't get enough 3D data to compute the point cloud, but it looks like it's going to work for this measurement. Then if I enter my last cursor onto the screen, I can move it down to this end. And by the way, this is when, look at my zoom window, that zoom window at the top. When I go to views and I go to HDR bright, I'm actually seeing the end of that line a little better in my 3x zoom window, the top circle. And I'll just show you what it looks like with other views. It's right in there somewhere. If I touch just one of the cursors, the cardinal cursors, you see it's moving a third of a pixel. I'm fine steering that cursor to the correct place. And now I'm putting my finger in the measurement value window and moving it to the side. And I now have data. I am not telling you yet that this indication has a given value. I'm just simply saying the point, the third cursor I placed at the bottom, is 193 thousandths to the line. And now if you look at the bottom value, the two cursors that are establishing the leading edge of that blade, I have them separated 292 thousandths, but I am not going to tell you those are the real numbers until I go to the views, I go to my full point cloud, I clear out the screen so that I can make it as big as possible. I'm simply twisting this with my fingers. I'm looking to see if I'm actually following the leading edge of that blade. And then I'm actually going down here to see if, okay, what is HDR variable going to do for me? Can I see, by the way, let me just get it up here. I want to see if I can see the end of that line any better in HDR variable. There's a bright view of it, and there's a darker view of it. I think I've done a fairly good job because I had adjusted the HDR to, and if that takes off like that because my finger slipped, I can just go to reset, start over. Yeah, I'm really close to, maybe if I touch that cursor and move it up to where it's maybe over here, maybe it's somewhere around 200, still 292 thousandths. So that is one way of looking at one type of indication on a compressor blade in a aero or aviation turbine. And there are many other measurement types that you could make on corrosion, pitting, welds, and those kind of things. And then, Tom, any other additional questions?
Yeah, Paul, we have a couple questions. So one question I'll take quick here. Are the dark boost, rotate image, and overlay functions only available when using HD probes? No, those are functions, those are software functions that are included with the handset, or this is the power unit, the processing system. And so you'll be able to get any of those functions, whether you have what we refer to as an SD probe or an HD probe, which is just really talking about the resolution of the camera that you're using. But as I said, some of these features are, you get them when you buy our loaded up package, which is called Analyze, or you can buy each of them a la carte as you want. And as I said, you'll get all these features in our current software. All you have to do is download our current software and have a Flame handset, as I said, and you'll be able to play with them for 90 days to try them out. The rotate image is something that is included in the software on all of our products. That'll be coming out again with a 3.5. Paul explained that's new. And then the dark boost and overlay functions, those are pieces of software that you can choose to purchase or not.
Paul, Tom, I want to add just one piece of clarifying on that. Yes, a lot of times people think about HD probes and they think about orange handsets and Flame handsets, and that is not necessarily one for one. The brand new Flame handsets can have a standard definition probe or a high definition probe, and it's the same thing on the gray handsets. If you invested in a gray handset with a 440,000 pixel camera, you can invest in a 1.2 megapixel camera. Regardless of which one is on that gray handset, we are not rolling back the software on that to update it and add dark boost or rotate image or overlay on the gray handsets. There is an upgrade program for that, but Tom, currently I don't believe there's any plans on gray handsets to add the dark boost, rotate image, or overlays, is there?
Yeah, no, Paul, and there's a reason for that. We're moving on from that particular product. It's like we're going up. So the Flame handset is a much better product, better LCD panel, faster processor. It's got a Windows 10 operating system, and that change from an embedded Windows 8 to Windows 10 has allowed us to do more things with the system. And so that's why we've been able to add these new kind of exciting and nice features with that product. So it's not a matter of we don't want to go back. It's just technically these are built for the new system. And that's the way we are rolling that out.
Yeah, big difference is Windows 8 on the gray versus Windows 10 on the Flame. So, hey, Tom, you said there was another question or two, and we've got just a couple more minutes before we wrap up. What else is out there?
Yeah, there's a question from a Baker Hughes employee, so colleague of ours, it sounds like, although I haven't met Gibran. I'm sorry if I'm pronouncing that wrong. Is there, Paul, a possibility to have a license of the latest software? I'm a Baker Hughes employee. I've already have the GE version from Mentor, but these features are really good. Did you want to take that one?
Yeah, Gibran, thanks for asking the question. And again, it goes back to this discussion about the color of your handset. If it is a gray colored handset, the latest software for that one is 3.17, and we made some updates in there so it was more compatible with menu-directed inspection, image documentation, and report generation. So, Gibran, though, on the Flame handsets, these software updates, a lot of these are going to be no-charge updates. When you update 3.5, you're going to have the rotate. You're going to have several of these. What you won't have, unless you invested in them early on, are things like dark boost, or there's a series of others. I think, Gibran, it'd be best if we had a more detailed discussion about what do you have and how do you get the new update when it's available in a week and a half, and then when you get that and it doesn't have the capabilities in it that you want, we can talk about there's an app for that, and how do you get the app to put in your device. So so he said, yes, it's a gray one. Gibran, thanks for that information. Feel free to reach out to myself or Tom or whoever your local sales manager is. They can certainly talk to you about which apps are available for that device, or maybe you want to invest in getting a brand new handset with a year's warranty on it, and all the things that Tom was talking about. It just depends on what you want to do there. So, Tom, Gina, it's at the top of the hour, and my first thing I want to do is thank every one of you for getting on the call and contributing a lot of information and good thoughts on the discussion. We will follow up with you. We will get information out to you on the questions, and you can also pull down the resources. You'll see 2 links, one for scheduling a call with one of my colleagues, and when you ask for us to come visit you or do a virtual demo with you, we'll be more than happy to do that. So please click on that. Please look for this information to come out after we consolidate it. And with that, I'm going to say thank you very much. I appreciate everyone being on the call. Be safe and take care.